Assalamu alaikum, meet Ismail, an absolute technology genius.
He'll take you from basic electrical theory straight into real, hands-on builds.
Hit subscribe for weekly explainers and let's start building today.
Welcome to This Explainer. Today, we're going to uncover a truly fascinating connection between the distant past and our modern world. I mean, think for a second about how completely normal it feels today to just pull out your smartphone, open up a digital map, and find a route to literally anywhere in the world with a single tap. We completely take it for granted, right? But what if I told you that this everyday convenience, this invisible network of data guiding you to your favorite coffee shop, is actually anchored in a brilliant and honestly nearly forgotten scientific discovery from the 9th century? It's true. Without the groundbreaking work done over 1,000 years ago, the satellite technology we rely on today just might not exist the way we know it. So let's kick things off with a pretty simple question. When you pull up Google Maps to find a quick route, who do you actually have to thank for the foundation of that underlying satellite data? Well, most of us would probably guess a modern tech pioneer, right? Maybe a 20th century physicist or an aerospace engineer. We naturally picture pristine laboratories, supercomputers, and massive space agencies. But the real answer takes us far, far away from Silicon Valley and way back in time. The foundational math and the sheer ambition required to map the globe didn't start with a computer chip at all. It actually started with human footsteps in the sand.
I mean, just look at the incredible leap we've made. On one hand, we have the 9th century, an era defined by raw, manual physical land measurements and complex mathematical observations made entirely by the human eye and hand. And then on the other hand, we have today, with automated satellites floating silently in the vacuum of space, beaming data seamlessly right down to a device that fits in your pocket. It looks like two entirely different worlds, but the secret linking them together is that they are built on the exact same scientific and mathematical principles. The space-age tech you hold in your hand right now is literally just the modern evolution of centuries-old fieldwork.
Section 1. Meet astronomer Al-Farghani, the mastermind behind the map. This guy was a figure of true global historical importance, essentially bridging cultures and continents. In the Eastern world, he was famously known and revered as Al-Farghani, but his work was so incredibly influential and his observations so meticulously detailed that his texts ended up being studied all over the globe. Because of that, his name was translated, and he became incredibly renowned in the Western world as Al-Farghanis. Regardless of how you pronounce his name, though, his impact on our fundamental understanding of the planet was just universally monumental.
Now, he definitely didn't achieve all this in a vacuum. After being born in Fergana, which is in modern-day Central Asia, he traveled to work in the ultimate intellectual hub of the era, Baghdad. This was right during the golden age of Caliph al-Mamun's era. So Al-Farghani wasn't just some lone genius tinkering away in a dark room. He was part of an elite, highly funded, and super motivated team of scientists, and they were relentlessly pushing the boundaries of both mathematics and astronomy. They were, without a doubt, the premier problem solvers of their age.
Section 2. The Sinjar Desert Experiment, a monumental task. Okay, so here was the actual plan, and it's wild. First, the team received a direct command from Caliph al-Mamun to find the true size of the Earth. Second, they assembled a massive team of scientists and traveled way out into the vast, unforgiving landscape of the Sinjar Desert. And finally, the execution. They undertook the painstaking task of physically measuring exactly 1 degree of the Earth's surface distance. Imagine this. They're tracking the angle of the stars overhead with wooden astrolabes, while simultaneously pacing and measuring the ground beneath them using calibrated ropes and rods. All of that just to capture a tiny 1-degree slice of the planet's total curvature. Section 3. Defeating double-digit errors, the astounding result. 25,000 miles. Just sit with that number for a second. By taking that single, meticulously measured degree and multiplying it out to a full 360-degree sphere, they calculated the Earth's total circumference to be approximately 25,000 miles. Relying entirely on 9th century tools, we're talking wooden instruments, raw human observation, and foundational mathematics, they arrived at a figure that is literally only a few miles off from our most advanced modern measurements. It is absolutely a breathtaking achievement in the history of human intelligence. To really grasp the true scale of their achievement, you gotta look at the precision. Earlier Greek and Indian scholars had certainly attempted this calculation before, but they struggled pretty significantly, often resulting in double-digit percentage errors. But Al-Farghani and Al-Mamun scientists, they achieved a staggering error margin of less than 1%. For that era, this level of accuracy was completely unprecedented. It was a total game changer.
Section 4. The Legacy of Accuracy, Timeless Science.
Because here is the fundamental truth about scientific progress. Sure, we have completely swapped those desert sands for orbiting space satellites. And yeah, we've traded wooden astrolabes for digital smartphone sensors. But the core scientific discipline, the dedication to keen observation, and the strict mathematical methods, they remain entirely unchanged since the 9th century. The foundational data of modern satellite technology was established back then. The only real difference today is simply the tools we use to read it. I think this thought perfectly captures the essence of Al-Farghani's achievement. History doesn't correct accurate work, it confirms it. When a group of dedicated scientists go out into the blistering desert and measure the world with less than a 1% margin of error using nothing but their minds and basic instruments, time doesn't erase that. Time validates it. True scientific accuracy is completely timeless, waiting only to be proven right over and over again by future generations and future technologies. So as we wrap up this explainer, it leaves us with a fascinating, almost mind-bending thought to consider. We've seen how perfectly the 9th century data gathered by Al-Farghani holds up today, seamlessly feeding into our satellite networks and daily commutes. It kind of makes you wonder, doesn't it? As we map the stars and gather massive, unfathomable amounts of data in our modern era, how will our current technological achievements be judged a full millennium in the future? What unseen technologies of the year 3000 are we laying the groundwork for right now? Keep exploring, keep questioning, and honestly, I hope you never look at your digital maps the same way again.